Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. We're going to be able to find Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an Lszh localized and landing. So right now I'm in the cockpit of the pre-takeoff operation of the quality wings and Marcus Flight Simulator X Boeing 787-900. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787 900 jet aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot to flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climate descent of the aircraft in 10 hundreds of pounds feet per minute, all the steepness of the trigonometric angles in degrees. You can climb and descend. We have also the artificial horizon with the attitude indicator, the pixel ladder in degrees and the bank angles in degrees, the Lszh localizer, the horizontal localizer and the vertical glide slope, and also the Lszh localizer crossbars. So we have the instrument landing system, the Lszh localizer transmitters from the airport runway, which are received the frequency from the aircraft on board sensors, so we can have the display of the horizontal and vertical guidance to the runway for takeoff or landing. And we can align, I usually align with the magnetic North Pole heading, so you will see also that of the runway, like in the Zurich International Airport runway 14, I have 136 degrees so of magnetic heading. So we have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and on zero with the autopilot and the auto throttle, later and vertical navigation modes. So we have also, you can see here, we have also the HSI just below the primary flight display. So this is the flight mode and on zero over here, and the primary flight display, the HSI with the standby flightman, the integrated flightman display. You can see also the navigation display that displays the GPS position, the inertial reference position of the aircraft, the terrain and weather reflections from the weather radar. You can see with red, green and yellow the reflections of the terrain around you, so you can avoid the terrain. When you fly and you have low visibility, for instance, you can see also the weather, the wind shear, for instance, when you fly, or thunderstorms and other weather other phenomena. So we have also the display of other aircraft that fly around aircraft using the transporter, the TCAS system. So we have the transporter, the DSP and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control, and it receives from other aircraft and displays the other aircraft with a diamond shape. You can see the distance when the other aircraft are located from the ground, when we taxi or when we fly, how far away they are, the distance they are located, the altitude difference with our aircraft, if they are above or below, and also whether they climb or descend with respect to our aircraft. We can have also this calculates, the computer calculates the velocity closing in between our aircraft and the other aircraft. If we are having an unminute conflict with another aircraft in the air, it will generate the TCAS system, traffic collision advisory system warnings. So we can monitor other traffic also here in the navigation display. So we have the terrain map with the airports. You can see the airports where they are located, the distance from our aircraft. You can see the blue color for letter account name over here of each airport. It's only airports displayed right now. We can have also the waypoints. It's pretty much the same. So you can see them also here. So we have here the display of airports, how far away they are. You can see also the runway we're gonna use for takeoff and for landing, the taxiway here in the airport. So we're gonna have the Lszh airport, the Zurich International Airport, runway 1449, let's localize takeoff and landing. I will tune the ILS localizer using the flight management computer. I already created a flight plan or a flight path or a route here. You can see the flight management computer. So I input all the data of the aircraft for this flight. That includes that includes the gross weight of the aircraft. That includes the takeoff gross weight. That includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and right wing, in the center tank, in the left and right wing tank, center tank. So this will calculate the center of gravity with this fuel on board and this cargo and passengers. Also, it will give us the minimum aerodynamic chord position of the forward wings. The Mach is the position with the maximum aerodynamic lift occurs in the forward wings. Is the position where the stall will begin for a given angle of attack and airspeed in flight. So we need to avoid the stall speed all the time. We can monitor also that in the primary flight display, and we have our airspeed has to be always above the stall speed, more than the stall speed margin. So we have also you will see how we're gonna use also that. So we have takeoff gross weight. We're gonna use the flaps for takeoff. The mean aerodynamic core position, the Mach is going to calculate the center of gravity using the fuel on board. Also, as we fly on takeoff, climb, cruises, and approach and landing, we're going to burn fuel all the time, so the center of gravity is going to be shifted in flight. So this also been calculated automatically using the flight management computer. So which has many modes of functions. So also this gives us the horizontal trim stabilizer. We're gonna trim the horizontal tail of the aircraft during the whole time from takeoff, climb, cruises, and approach and landing. So you're gonna see also that either automatically using the auto trim function from the autopilot and flutter system panel and the auto throttle, or we can use the manual trim switch in the control wheel of the yoke of the Boeing 787. So you can see here we can trim the horizontal tail of the aircraft like this, trim up and trim down, having this switch here. So this trims the horizontal tail of the aircraft, trim up and trim down and trim up to pitch up and pitch down like this the other way. So you can see the pitch trim position here displayed in the ACAS display, instrumentation and control system display, or multifunction display as we call it. So you can see nose down or nose up, 4.25 degrees. The green band here is for takeoff limit. You can see the stabilizer. We have also the rudder trim, the flaps position, other things, landing gear, extend and retract, alternate gear here, lock override, auto brake for landing or for ejector takeoff. So we have also the indications from the engines, the left and right engine, as you can see here. I will explain later. The gross weight of the aircraft and the total fuel on board, the temperature of the fuel, some indications, some warnings. So I'm talking about the horizontal trim stabilizer when we fly with the flight controls manually or automatically. So this is the exterior view of the aircraft. As you can see, the horizontal tail stabilizer is this plane form, so we can trim up or down, moving up and down the whole surface area of both left and right, a horizontal tail left and right. And we have also the vertical tail, we can trim also that in flight. So you can see here is the longitudinal axis that transverses the horizontal tail. We have the thrust vectors from the engines. I can see the surface area of the wings holds the aircraft weight when we fly. We have the mean aerodynamic chord position. About here is the maximum aerodynamic lift position. Is the position we calculate the center of gravity. Also the stall will begin. The airflow from the top surface will become detached for a given angle of attack of the aircraft and airspeed and altitude. Flap setting. Let's see, we're gonna have to avoid the stall speed all the time. So you can see the flight controls movement also as I move this. We can use also the elevator from the horizontal tail instead of using the hull. You can see also the bottom surface of the wings. You can see they are more flat. So when we fly with an airspeed for flight, the airflow is moving slower below the wings because it's more flat, using the Bernoulli theory of fluids and Newton's physics. So there is higher air pressure below the wings, which pressurize the aircraft weight up into the air. Also, you can see the top surface of the wings is more curved. So using the Bernoulli theory of fluid and Newton's physics again, you can see the airflow is moving much faster above the wing, so there is lower air pressure, which sucks the aircraft weight up into the air. So this is aerodynamics and aerospace engineering principles. You need the basic you need to know. We have also the deflection of the airflows using, I'll talk to you now about the flight controls of the aircraft. So you can see the horizontal trim stabilizer here. I told you, trim the horizontal tail up and down like this. So this is down, up, like this. See the position here, how many degrees, trim up and trim down. And we have also the alternate pitch trim here. You can see alternate pitch trim up or pitch down. Also the parking brakes besides that. Over here, this handle. You can see also this red carded switch. We have the cutoff switch, the L2 and R2 hydraulics, stabilizer trim. So we have a failure of the hydraulics over here. We're gonna have the L2 and R2. So we're gonna have a failure of the auto trim function from the autopilot, flight director system panel, and the auto throttle. So we won't be able to use the auto trim function. We need to come here and disconnect from normal over here to cut off position. Then we can use the normal trim all the time, alternate maybe. We have the mouse pad also over here, the cursor, so we can use the manual trim all the time. We have also the autopilot disconnect. So I'm gonna show you now the flight controls of the aircraft, perhaps. Autopilot, flight director system panel, later thrust levers, all the systems, and we're gonna make an engine start demonstration. Let's see also that. So I'm gonna show you now the flight controls of the Boeing 7. The flight controls of the Boeing 787-900. I'm gonna show you how I use the joystick, the Logitech String 3D to control the function of the Boeing 787 flight controls. I use to control the yoke of the Boeing 787 and the rudder pedals and the nozzle steering. So we have the yoke, the control column, the vertical column to pull up or climb the aircraft using the elevator, and also to descend using the elevator again. We can also make bump roll turns using the ailerons and the spoilers using the control wheel. So we have also the rudder pedals for vertical rudder yawing turns in the air. Also for nozzle steering the ground, it's interconnected with the tiller until some airspeed, like 70 knots. Then we have the rudder and the function when the rudder is aerodynamic effective in the runway for takeoff. So we have also the toe brakes and the rudder pedals. So the elevator in the control column and the column pulling up and pulling down like this. So you can see now. I hope you have a better view like this. Maybe light. Yes. So I think you can see I can climb and I can descend the aircraft like this. I can make turns, right turn, left turn, like this. Also use the rudder pedals. I can also use only climb and descend, or make turns left and right in the air. Only the rudder pedals, whatever I like, or all together coordinated flight. So we have the horizontal trim stabilizer. Also we have the tiller here, nozzle steering, the flaps and the speed brakes, speed brakes, the thrust levers also. You can see the thrust levers moving forward or aft when I use the thrust levers forward. So we can have both thrust and flight controls. Actuation. You can see the seismic deflection here is proportional to the yoke deflection. You can see also both the captain and first officer flight controls and rudder pedals, the yoke control wheel also, the control column and the control wheel, and the rudder pedals will move together simultaneously. They're interconnected for the whole flight from takeoff, climb, cruise, approach, and landing, unless we have a failure. So it's not like the Airbus, you have a priority in the side stick from either side. So maybe I will show you also a little bit this view. So I will show you also the outside view in a couple of seconds of the flight controls that you use with side stick. Maybe I will show you also this view here. You can see again, it turns left, right, climb and descend like this, or maybe better view like this. This is the flight instruments moving, flight controls. This is seismic deflection proportional to the yoke. It's like in the Airbus aircraft, and also the thrust levers here, forward and aft. So now you're gonna see the outside view of doing the same thing, controlling the flight controls here. So you can climb and descend the aircraft like this, make turns left and right using also the rudder, or climb as you can see here. So you can see the climb part, this climb. You can see also the APU exhaust here, and the elevator, and the horizontal tail that we can trim. So maybe you see better the side stick deflection like this, the tail plane form. So we have also ailerons and spoilers. So this is all the controls of the function of the Boeing 787 flight controls. Now we'll show you the inside of the cockpit, the rest of the systems. So that was all the flight controls tonight. Hope you like them. Was the trim stabilizer, climb, descend, make turns right, turns left. So I will show you the rest of the flight controls. Autopilot, flight director system panel, head-up display, the display of the engines, the ACAS, the flight management computer over here. You can see I input all the data I told you about flight. So I input the minor dynamic core position is calculated using the takeoff gross weight, the passenger cargo and the fuel on board. The center of gravity, the trim for the horizontal tail is calculated from this computer, the flight management computer. We use the takeoff runway, Zurich International Airport runway 14, Lszh, and the runway length, the runway slope, the wind direction and speed, the barometric altitude, the pressure of the air, the density of the air, also whether the conditions of the runway, if it is ice, dry or wet, and it's gonna give us the takeoff speeds, the V1, V rotate, and the V2. plus the takeoff speeds after V2 plus 15 knots for the initial climb. I insert also the seeds, the other instrument departures, waypoint and fixes that include horizontal vertical navigation fixes for the initial climb of the aircraft. The top of climb, the cruise level, I selected 25,300 feet. I will fly also later after that 26,000, 27, 28, 29, maybe 30,000 feet. So we have the cruise level over there, we have the top of descent. We're gonna initiate the descent back to the airport into a lower flight level from 29 or 28,000 feet back to 6,000. For the terminal approach, we have the stars, the standard terminal arrival waypoints and fixes. Also inserted in the flight management computer. It's gonna align us with the runway heading, the long final and the short final. We have horizontal vertical navigation fixes, altitude and airspeed constraints, also the Lszh localizer. We're gonna use the instrument landing system of the airport runway. We're gonna align it with the magnetic north pole heading of 136 degrees, and we're gonna have the horizontal localizer and vertical glide slope and the Lszh localizer cross-bus displayed in the primary flight display following the airspeed and the vertical rate of descent. We need not to have like more than 500 feet per minute or less, like 300, 200 for touchdown in the runway of vertical speed over here. So we're gonna follow the vertical speed indicator over here during touchdown, and also we need for takeoff and for landing not to have more than 9 degrees of pitch attitude of rotation. 9 degrees because we're gonna have a tail strike in the runway as we climb for takeoff. So we're gonna have for landing, you're gonna see during the rotation. I'm gonna show you over here the flight management computer, the inputs I did, so you can see the initial lies here, the index we can select over here, performance, takeoff position, ident. So performance, we have gross weight, fuel on board, zero fuel weight over here, reserves, how much fuel need for reserves, fuel on board 35,000. So zero fuel weight plus fuel is gross weight over here. Cruising altitude over here, you can see with the magenta color when I select. Cost index, fuel temperature minus 37, cruising center of gravity. So we have the route, departure, origin, destination, runway departures over here. I select runway 14 and the seats. Then arrivals over here, selected Lszh 14, and we have over here the route created by selecting only departures and arrivals. You can see from takeoff the altitude and the airspeed and the heading after takeoff, the first intercept. Then as we climb higher, 6,000 feet, the Zui with an airspeed of 302 knots. Then the Nigra flight level 22,100 and airspeed 302 knots. Then we start the descent, Mativ 320, 11,800. Then we have the Alpha 7,000, 6,000 Alpha. Then airspeed of 180 for the terminal approach over here, and landing runway 14 approach. So we have selected here the flaps for takeoff using this runway, 15 degrees, center of gravity 23% with the minor dynamic chord position, 23% of the chord, and the takeoff phase V1, V rotate, and V2 for this gross weight. So this is all the calculations. You have the legs displayed here in the navigation display over here. You can see so we have the display of the legs from here. This creates the flight plan route you see here in the purple color from takeoff, climb, descent, approach, and landing. Maybe you see better here. Also the vertical, not clear. You can see how far above the ground you're gonna be as you're flying. Also, like 8,000, 16, 24,000. So you can see the terrain in front of you. You have some mountains. You see the flight plan also here, and also the plan mode. So we have also, if we look further away, we're gonna have the descent also. We're gonna have cruise then descent over here, and the cross of the also, if we look for more close, you will see the runway. We have the terrain in front of us. So this is runway 14, the taxiway and the runway beside us. So this is runway this way, and the taxiway displayed in the GPS system here of the aircraft. You can see this is the actual, like in the display over here. So you can see this is over here, runway in our position, displayed with this triangle over here. The magnetic again heading. So we have over here the plan. You can see again the position of the aircraft without the taxiways. You can see from takeoff we have to take off this way, climb, cruise, then cruise over here, make a turn, then approach and landing over here, the terminal approach and arrival. This is the plan mode. So maybe we'll look a little bit closer. You can see some airports also further away. So this is the top of climb over here. So we're gonna have a lot of things. This is the navigation display, navigation data instrument. You can see also the airspeed indicated, the airspeed selected. We're gonna change this value, also altitude here, different values for all these. I'm gonna come here. You can see the autopilot. We have the engage and disengage switch here. Engage and disengage, the airspeed select knob, the bank angle and heading, the vertical rate of climb descent of the aircraft, and the altitude. Select also the roll localizer, the approach for alt1. So we have over here auto throttle left and auto throttle right. It will move only one thrust lever. It will use only one other side. So we have also a nav here in VNav. We select, you can see, you can select again. If we turn off the flight director like this, it will disarm both modes. We cannot arm the autopilot like this without the flight director or in any mode. So we need the flight director first on, and then we have back the modes. We have the autopilot disengage here. You can see the pilot disengage. The airspeed, we can have the flight level change, climb continuous, and auto throttle, X transfer, indicated airspeed or Mach. So a few things we need to know. I use this airspeed, bank angle also. Heading, I'm gonna select a heading, take off. We'll leave it at auto, so we're gonna have the magnetic nose pole heading. You can use heading or track, the hold also, switch for that, the altitude here. Also we're gonna select thousands. 5,300, the vertical speed. So you can see zeros, you can see descent like this, descent from the cruise level. Also we can see the climb. You will see the plus over here, and now we're gonna climb like 2,500 feet per minute. So I told you roll localizer also, and auto land function of the Boeing 787. Now we have a few more displays here, also in the head-up display, target airspeed, target altitude, same like here in the primary flight display. Target airspeed, target altitude, nav and VNav, vertical speed, flight director. You can see the airspeed indicator is selected from the autopilot flight director the barometric altitude above the sea level. Target altitude, the pitch ladder degrees, 2.5, 5, 7.5, 10 degrees, 12.5, 15, 7.5, 30, climb or descent. So you need to pay attention also pitch altitude and also vertical rate of climb descent, 10 feet per minute, because you might have a positive pitch altitude in flight, but you might go now falling. You might have a vertical rate of descent. So you need to know exactly, you need to follow the vertical speed indicator all the time. We have the radio altitude above the ground, about radio over here, 3992 inches of mercury, the barometric pressure setting. So these are all the instruments we need to have. The air data control computers also I forgot to mention over here in the overhead panel. You can see heading reference and IRS, inertial reference system for alignment. So the air data like pitot tubes, angle of attack of the aircraft, GPS receivers, magnetic north pole or geographic north pole. Also laser gyroscopes are controlled by the air data computer over here. So the displays are the pitot airspeed and altitude and rate of climb descent, and also laser gyroscopes for procession or deceleration of the aircraft and altitude. So these are controlled from the air data computer, GPS position, terrain also around you, angle of attack as you fly. So this is the air data you need for the flight instruments and navigation. So we have also I'm gonna show you now the overhead panel. I will talk to you a little bit more about the flight controls. So the airspeed, here we set the airspeed guidance of the aircraft. I'm gonna show you also the thrust levers here. We have the thrust levers. You can see the auto throttle disconnect switch over here. So you press this and you disconnect the auto throttle. We have the takeoff go around. We have the thrust reverse like this. So this engages the thrust reverser and extends the speed brakes. So reverse thrust. See the reverses are open. Over here you can close the thrust reverse. So this is how it arms. If you move back to the idle and move up, you see the thrust reverse, and this sounds like this. So we have also the indications of the engines. I will talk to you now. We have the fuel control to the left and the right engine over here. The fuel flow for the left and the right engine, fuel control, on and cut off switch, the flaps over here, position, retract or extend, speed brakes also. This is speed brakes. Horizontal trim stabilizers, fire extinguishers for the left and right engine, closes of the fuel control, the transponder, radio communication panel, rudder trim. So we have more instruments here coming now and functions when you start the view. So we have the engines here, the left and the right engine indication. So we have the GNX engine on our Boeing 787-900 aircraft, one on the left wing, one on the right wing for symmetrical thrust, and that one contains a gearbox with the FAREX. The FAREX are the full fluid digital electronic control computers, one installed per engine gearbox, dual channel redundancy, one channel fades, the other takes over, controls, monitors, and displays all the engine data and functions you see in the upper and the lower ACAS. Also the multi-function display, like the N1, which is the low speed status of the pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine. The N2, which is the high speed status of the high pressure compressor and turbine of the turbofan, which is engine. The fuel flow per inch per 1000 kilograms to 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have also the fuel metering unit. We have the fuel heat exchange sensors. We have to heat the fuel in flight all the time for not cooling down, freeze the fuel. by using the recirculation system to the engines, also the oil, and this has sensors which are controlled by the Farex. So the oil heat exchange sensors from the engine duct some heat. So we have also the pressurization, the bleeder. We can turn off the pressurization panel here now for a second. You will see the bleeder, the outflow valves. So this pressurizer from the 5th and 9th stage. You can see also from other sections. So we have cabin altitude right now, rate of climb, the differential pressure of the cabin pressurization can go up to 7.8 or 8 psi landing altitude, and the outflow valves forward enough for this cabin pressurization. So you can see here the N1, which is low speed stars, have low pressure compressor and turbine of the turbofan tube engine, the left and the right. Low pressure, low speed starter and stuff, low pressure compressor and turbofan tube engine, left and right. Exhaust gas temperature per engine in degrees Celsius. The N2, which is the high speed starter shaft, the high pressure compressor turbine of the turbofan tube engine, left and right. You can see 19.8 idle, 100.4 with green is the takeoff limit, with the green over here, also the yellow and the red, the never exceed limit. We have some warnings with yellow or amber color, parking brakes and doors. So you can see the fuel flow per inch per hour, 1000 kilograms, 1000 pounds, oil pressure, oil quantity, oil pressure, oil temperature, oil quantity, and the vibration within 2 states of the engine. So the Farex also control, as you see, all this data, the engine start, engine shutdown, engine failures, fuel and oil exchange sensors for the heat of the fuel and the oil in flight. We have also the bleeder from the 5th and 9th stage, the pressurizer from the 5th and 9th stage of the starters, of the high pressure, low pressure and high pressure. Also from the bypass air from the fans, from the front fans. So this is used for cabin pressurization of the aircraft cabin in flight. As we climb and descend, we change the pressure of the cabin and the altitude. For hydraulic fluid pressurization, we need pressurizer from the engines or the APU as a backup. So we need all these things you see here: the flight controls, the tail, the rudder, the horizontal elevator, rudder pedals, thrust reversers over here for the engines, landing gear, extender, retract, parking brakes, auto brakes, nose wheel string over here in the ground, flaps and slats and speed brakes, so ailerons and spoilers also. So all these flight control surfaces you see here moving are using hydraulic fluid, as you see. Pressure from the engines, bleeder. You see we have engine driven and electric driven. I will explain later in a couple of seconds. So we need hydraulic fluid tanks, pressurization, wing and engine ADIs, and air conditioning, ventilation and cabin pressurization. Also we need the APU, the auxiliary power unit, a smaller turbine in the tail of the aircraft. We use only for aircraft for alternate current for electric power when we have the engines off and we need to start them, and for pressurizing the engine starter during the engine start in a cold and dark aircraft. So before the ignition of the fuel, so we need I will show you also that. So a few more things. The Farex also, as we climb the aircraft from the sea level all the way up to like 20, 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea. The pressure of the air, the temperature, the oxygen level are becoming less than half than that of the sea level. Also the temperature of the air is becoming freezing, like minus 30, minus 40, minus 50, minus 60 degrees below zero. So also as we climb higher, the aircraft will fly with an airspeed rate of about 2 or 3 times faster than that of the sea level. So we can have a higher intake of air mass, airflow from the front fans of the engines into the compressor for compression and fuel mixture and burning. So we have different fuel mixture requests every second as we climb, then vice versa as we descend. Is becoming the inverse. So we have a different fuel mixer request every second. This is adjusted automatically every second using the Farex. So the full authority diesel electronic control computers installed in the engine vehicle. So it's a good thing to have the Flught installed into your aircraft. So I will show you now here the overhead panel. We're gonna make the electrical. You can see the battery, the APU generator, the generator controllers, 120 to 200 volts, 400 Hz frequency. We can disconnect them if we have a failure. The APU. I'm gonna start the APU now. Use the default. APU generator, external power also. The primary flight control computers are in the auto position. Heading reference, IRS, master reference system, flight control computers, some other systems here. The door, passenger oxygen, window heat, rammer turbine, hydraulics. So we need the hydraulics here. As I told you, hydraulic pressure. So we turn them off like this. So the primary and the demand here of the left and right engine, we have the electrical on. We keep having power. We can also turn them back on like this. You'll see. So let's turn them in the auto position. We have also the lighting system and the windshield wipers, the fuel on board, the left and the right fuel tank, the center tank, the crossfeed valve. We can use either fuel booster pumps for the raft, the balance. We can use the crossfeed valve itself to feed either left and right engine if we have a failure. So we can feed either engine with either tank or either pump using the crossfeed valve here. And also we can balance the fuel between the left and right tank. We have the wing and engine anti-ice here. Back to the auto. Pressure. Fuel jettison, we can dump some fuel in flight like this. If we arm this and select the nozzles and how much fuel to remain. Electronic engine control for the engine, left and right, normal and alternate mode. Engine starters over here, normal and start. APU and cargo fire, some other also systems, and the pressurized air conditioning here, cabin pressurization, also pressurizer from the engines and from the APU. So in the manual mode we need to use the outflow valve, so climb and descend and select the landing altitude. We use the auto. We have also here the pressurizer system from the engines that I explained you. So now we're gonna see all these things in the overhead panel. We just see we're gonna see them in a digital format over here in the display. So this is the last thing before doing an engine start demonstration. So we're gonna make an engine start and then proceed to fly. So also need some lights here. So I'm gonna show you the displays here. Last thing before making an engine start demonstration. So we have systems. You can see the hydraulics, 5000 psi, quantity, rotation per minute of the APU. Also oxygen and liquid cooling. Also you can see the systems. You can change from here. So we have the electric over here. You will see now all the diagrams, like the electric is the same over here, all the switches, also the hydraulic later, the fuel system and the air pressurization. So you will see all the systems are in a digital format display over here. You can see the APU is running, APU generator, the contactors 180 to 200 volts, 100 to 30,000 kilovolts, 400 Hz frequency, electric power, left and right engine, load set, main battery voltage and APU battery. So we have also a hydraulic system over here, where the hydraulic system goes, hydraulic fluid goes, 5000 psi left and right engine, also the center, the electric C1 and C2, shut-off valves over here, primary and demand engine driving, and the quantity 5000 psi pressure. So we have the engines here, and the fuel tanks. So you can see the left and the right wing fuel tank, how much fuel you have in the left and the right wing. Also in the center tank, 11,000, 11,000, 12,000 pounds. You can see the total 34,400 pounds. You can see the low and high pressure fuel valves in the left and the right engine are open and feed both engines from the center tank. Right now using the fuel booster we have the aft and the forward. The cross feed valve is off, but if we turn it on, can feed either engine with either side pump or tank, and we can also balance the fuel between the left and the right side if we have a fuel imbalance. Also here you can see the minimum fuel temperature is minus 37 degrees Celsius, and the fuel temperature right now, so at minus 37 you need to avoid. We have the recirculation of the fuel all the time from the tanks into the engines using the fuel recirculation system to deduct the heat from the engines and cool them down, and also heat up the fuel so it won't freeze in flight. Also for the oil that is being recirculated from the engine parts. So we have here automatically using the Farex, the air system, pressure inside the cockpit and the pressurizer from the engines. The doors are closed, the cabin can be pressurized, the gear, the temperature of the brakes here, and the pressure of the tires, flight controls. Here again you can see we can use the flight control system. You can see everything is working here in the display. So this is very important. You see all the flight controls, ailerons, spoilers, flaps, elevator and rudder pedals, and the horizontal trim stabilizer position and the rudder trim. Everything is normal. So we need the FS display maintenance, which is done with the digital way. So we have only one last thing, checklist over here, resets, menu, normal. What we need to do here before start, before takeoff, after takeoff, descent, approach, lighting. So this is the last thing. We have communications off, the navigation display, back, and we need to restart the engines now. I'm gonna turn off both fuel control off like this. You will see the engines are off. You will see some systems are popping up. Fuel control and 2 decreases. So you can hear the sound of the engines is decreasing, right and the left. We need to come over here now in the overhead panel very quickly and start both auto start, left and right. So you can see the auto start has kicked in right now. You can see the N2 is increasing above 20%. You will see here both engines have only pressurizer right now. We can let the fuel flow here, the fuel control on like this, and you see the auto start is kicking in, both left and right engine. You will see as it increases, as the engines are coming back to life. We're gonna have the systems here going off, going on actually, the warnings going off. So auto start right now. You can see all pressure ratios. So we have all the systems on, the warnings go off, auto start, and we're gonna have the running over here, both engines running message. So now we can go for takeoff. Last thing to do, flaps for takeoff. So we take the clearance for this runway. So I'm taking the clearance for this flight. Thank you very much for watching. Until now, I'm Thomas Hatsios, American pilot flying Boeing 787-900. Now we're gonna proceed for takeoff, climb, cruises, and approach and landing. So you will see the complete flight. Stay until the end part. So disarm the parking brakes, advance the thrust levers over here. So we taxi into the runway. Use also the tiller here. Do some braking here and align with the runway. So we need to advance the thrust levers forward and align with the runway. And this is it, we take off now. So we have 80 knots, 117, V1, we rotate, pitch up slightly, maximum takeoff power also. So you can see we take off like this. You can see also the outside view. Landing gear up. So we have like 18 more minutes left for this flight. Keep climbing. You can see we are 1,000 feet above the ground. Keep climbing. And it also pitch down slightly. So we are 1,700, 1,800 above the ground. The airspeed is 240 knots. 2,000 feet above the ground. 3,700 above the sea. We climb with 4,000 feet per minute. The pitch altitude is like 10 degrees, 12 degrees right now. You can see the first waypoint we have to cross over here. The climb rate, the terrain below us, the terrain in front of you, the engines, power thrust. So we need also change the monitor display. You will see some red now. If you look further away, you will see some mountains in the map. So now we need to start, I believe, in a couple of seconds. So this is the view from outside. Over here, the Switzerland, very beautiful, the lake, and this Switzerland Alps. So we need to start the turn now. Over here, and we have 16 more minutes left for this flight. You can follow the turn here. You follow the instruments when you have no view outside what's going on. So you follow the instruments, that's why you have them here. You can see also the GPS position here. I'm gonna change the view, make it closer. As we climb, one more turn. Increase maybe the airspeed like this. Climb with a higher airspeed rate right now. So we have 14 more minutes left for this flight. So we're gonna make a small part of the flight again and turn back shorter. So you can see the view here. Boeing 787, beautiful view. So we're gonna have also up move up some flaps now to increase the airspeed, to make some small turn like this. We need to follow the flight line here. As you can see, this line, we're gonna make some small turn now. Use some rudder pedals also, right rudder from time to time, or left rudder. Now we need a little bit more right and some ailerons like this. So you can see we can fly hands off like this whenever we need. We don't need to hold the flight controls all the time, but the aircraft we keep following its trajectory if we have enough thrust and trimming in the right way. So this again hands off, as you can see, without the autopilot aid. So we need to pull up the flaps right now like this. We'll have also the stall over here, the margin, but we're gonna have an increased airspeed now. The airspeed, the stall speed here, the warning, the max speed 0.5. Right, we're gonna have to level off for a while. You can see we have the LNAV on. So higher airspeed now, we have the LNAV indicates the airspeed to higher rate. So we're gonna be flying over here, very close to the lake of the Switzerland over here. The Germany, the Bayern Munich in front of us, the France this way also, and the galaxy, the full galactic view over here. The France, the Italy in this side, and the Switzerland. So you can see the lakes over here and the galaxy from this side. So we have 10 more minutes to go. So 10 more minutes to go. We need to start making a turn now, I believe, over here. So we're gonna initiate the turn. We need to go back to the airport. So you can see as we turn, we have also the view of the Germany, Bayern Munich, my homeland here, and the France in the other side, the Switzerland here, and the lake. So you can see again we fly hands off again while taking the turn. We don't need to have time. So we're taking the turn early, and we have 9 more minutes to reach the airport. So we're gonna be flying a little bit higher, with a higher airspeed. So here we need to make a sharper turn to follow the flight line. So we are 28,000 already. You can see we're taking the turn here. Back home. Need to complete the turn first, back to the flight plan. So here we are aligned right now. And we have 8 more minutes to get into the home. So this is our galactic view right now. Very beautiful. With the chemtrails and the contrails. Chemtrails. And the galaxy here. So you see the frozen vapors as we fly. Back. We can also tune the autopilot, I believe. So give us a rate for descent. We cross 31,000. So we have 6 more minutes left to adjust the thrust here for descent. Initiate the descent. And we have 6 more minutes left for this flight. So we are descending like this, as you can see, back to the airport. So we have the chemtrails here, as you can see. The lake over here, the France. So I'm gonna descend even lower manually with a maximum airspeed right now, as you can see, and we're gonna divert some waypoints over here. So we're gonna use some speed brakes to increase the rate of descent, and we're gonna have also over here the altitude. Back vertical speed. So we are descending right now. For approach, we have 4 more minutes left. And for landing, so this is a faster approach like this. So we keep flying manually like this. Now we're gonna be flying faster approach, like fighter jet way. So we have 3 more minutes. Need to use also some flaps, and we believe we need to do three more minutes left to fly manually. Have to cross all the clouds over here. So we're gonna be aligned with the runway in a couple of minutes. So here we have the runway inside. So here we are. We have all the indications correct. The airspeed need to decrease a little bit. So as you can see, we are in the Lszh localizer over here, very close, aligned. You can see the indications. So we need only add some flaps. We have more or less 1 minute left for this flight to end, so we need to reach the point a bit faster. So here we are. Decrease the thrust levers. And we have a few more seconds left before the video will end. So here we are, flare, touchdown, parking brakes, and idle thrust and reverse over here. So we are aligned, idle thrust, reverse,